this video, I'll explain two questions from the practice final exam. Okay, so question number 41 and 42. They're related. Okay, so both of them are calculating equilibrium constant. Okay, and then so I'll explain both, and then you see what, right? Okay, the core is the same, right? It's all about we're calculating equilibrium constant, and but you given with certain information, and then the the really important part is how you can get equilibrium constant with given info, and then what's the major equation you need to know in order to solve this type of question. Okay, and then of course you probably see from this half we have been talking about equilibrium constant a lot, right? So from when we started to touch about equilibrium reaction equations, so we talk about how to calculate the equilibrium constant, and then we acid base we need it, right? Okay, and then even when we come to Gibbs for energy we need it, and then when we get to electrochemistry we also will be able to calculate equilibrium constant. Okay, so it's very important concept. Okay, so anyway, so let's look into these two questions. Okay, so the first one, again, clearly we're calculating k. Okay, let's see what's given. Okay, so then from this question, where we're given with the balance equation, okay, and then we're given with the Gibbs for energy for each substance. Okay, so we have the value for reactants and products. Okay, and then you go, K, how can I calculate K? Okay, so and then it goes related to Gibbs for energy, then directly you should be able to connect this two concept with this equation. Okay, so this is equation we're talking about, right? At equilibrium, of course, we're talking about equilibrium constant, right? At equilibrium, delta G naught, right? So which means what? Which means under standard conditions, right? Okay, so delta G naught will equals to negative RTL in K. So this is one of the equations we have mentioned during the lecture. Okay, so again, this is the equation is linking, right? Is link this delta G naught with equilibrium constant with us. Okay, so there you go. Oh, okay, so now I just need to know what's delta G naught. Okay, and then for this, of course, this system we're looking at is a reaction. Okay, and now of course you're given with information for the individual Gibbs for energy for the reactants and products. Then we could calculate this we could calculate that first. Okay, so that will be the strategy. Okay, so by knowing we have to use this equation, and then we're gonna use it, right? Okay, so then the way to use it, I had to know what's the Gibbs energy for the reaction. Okay, and then the next, which is related to one of the three ways how to calculate Gibbs energy for a reaction. Okay, so this is the easy way, right? So this will be, we'll just simply calculate delta G naught of the reaction will be the sum, right, of the product. Okay, so then you have G of the product, and then you're gonna sum up the reactants. Okay, so as I keep on saying, right, you don't forget about the number of moles. You go, where do I get the number of moles? That will be the coefficients. Okay, so this will be just one. If nothing's there, that's just one. Okay, so that will be let me erase that so it's easier to see this, right? So that will be one over here. Okay, so this is how you can use this equation and then to calculate delta G Gibbs for energy for the reaction under standard condition. So that's what this telling you. Okay, so then with knowing all that, we can just plug in the values. Okay, so I will I will I will I will actually plug in the values. Okay, so then you're gonna use products. So I'll go 3 moles. Okay, so I'll use 3 and moles times 51.3 kilojoule per mole, and then add 1 mole will be water. Okay, so times the value, that's negative 273.1 kilojoule per mole. So that's your product. Now we're gonna subtract the reactants. Okay, so that will be 2 moles. That's over here. Okay, 2 moles times 110, negative 110 kilojoule per mole. And that'll be 1 mole times 87.6 kilojoule per mole. Okay, so now you do this, put all that number into a calculator, you'll be able to calculate the answer will be 51 kilojoule. Okay, so then you get a 51 kilojoule. Then at this moment, you have to think about, delta G naught of this reaction is 51 kilojoule. Okay, so what does it mean to me? What does it mean to me? Is it spontaneous towards product side? Then if you were paying attention, right, you go, no, delta G naught needs to be smaller than 0, which means it's spontaneous favors towards the product side, right, spontaneous to the product side. So this is probably not. Then you're probably anticipating your K is not going to be bigger than 1. It's going to be smaller than 1 because that's also one of the relationship you needed to know in terms of spontaneity and K and Gibbs for energy, all this relationship. Okay, so that's one thing. Like I said, if you know what the question's about, right, what spontaneity relationship between K and if it's positive delta G or negative delta G, you actually could eliminate some options. Okay, so A wouldn't be your option. Okay, A is too big, it's bigger than 1. You're looking for a value smaller than 1. Okay, but no matter what you go, well, I didn't think about that. Just look at the number. We can just continue to the calculation. Okay, so you get 51 kilojoule. Then you go, okay, so I know this value now. This is, we just calculated, that's 51 kilojoule. Okay, and then that we can just directly use this equation to finish off the calculation, right? Okay, so then we just use that. I'll use the spot the space up over there. Okay, so now we know 51 kilojoule equals to negative R. We're going to use 8.314. The reason for that is the units are convenient for us, right? And since we're using this value, we know, right, it's a Kelvin, so we need the temperature to be Kelvin. And then you see, okay, temperature is over here, 298. Okay, so 298 K, and then you're going to multiply ln K. And then K got cancelled out, okay? And then you go, oh, another little tricky part, right? That's kilojoule. Over here is just a joule, so I need to do 1 times 1,000. And now I'm gonna divide it, right? Okay, so divide that and 278, okay? And then you'll get ln K. Okay, and now again at this point units are fine because equilibrium constant, right? And we in this case we just count it as unitless, right? So that K is fine. Okay, so then you can get this value, okay, and then you be able to calculate K, right? So you can get a value over here, then you're just gonna do e to the power to calculate K, okay, and then let me just get a value for you. Okay, so you're gonna use, right, 51 divided by 8.314, then divided by 298, then you're gonna get this value turns out to be negative 20.58, and then I'm gonna take, okay, 20.58, okay, and then you get 1.15 times 10 to the power of -9. Okay, so that will be the answer for this question. Okay, so then of course that matches choice C. Okay, so you recognize this question actually combined two equations. The first step, you needed to know how to calculate Gibbs for energy for a reaction, and then you know what's the relationship between Gibbs for energy and equilibrium constant, okay, by using that equation and then do the calculation. Okay, so this will be question 41. Okay, so this is one way how how to calculate K. Okay, so now let's look at the second one. Okay, question 42. Okay, so for question 42, again, calculating equilibrium constant one more time. Okay, And then you go, okay, so this looks different, right? But then no matter what, you know, in order to calculate equilibrium constant, okay, so you go, I need this equation, right? I need delta G now equals negative RT ln K, okay? So in order to calculate K, you need delta G naught, right? Okay, and now of course you need the temperature. Okay, so you need those two and temperature is given. Okay, so then you can just go from this point, right? You go delta G naught. How do I calculate that? You go, oh, this is nice. I know delta H and delta S. I know the relationship between that will be delta G naught equals to dot H naught minus T dot S naught. Okay, so then you go, oh, okay, so I see I can use this equation, calculate delta G naught first, then put inside there, then can calculate K. You see, the core for these two questions are the same, right? You need this equation to calculate K, but the way how to calculate delta G are different. One question giving you delta G F, right, for each reactants and products, and this one give you delta H and delta S, then you still will be able to calculate delta G naught. Okay, so then again, right, the core is the same, the office are different, but if you know the concept, not a big deal, right? Okay, so since we know all this, let's start do our calculation. Okay, so then we'll just put in the values negative 304.2 kilojoule minus T temperature is 498 K times this value will be negative 414.2 joule per K. Okay, again, remember as we introduced to you, entropy delta S, right? Okay, that's smaller as units is joule. Delta H units are bigger, kilojoule. So make sure you convert both to the same units and then do the calculation. Okay, so that column go cancel out and then you can do the calculation. So this is kilojoule, and then I'm gonna multiply divided by 1000 so that I can get to kilojoule. I did all that, okay, and then I get to 206.3 kilojoule. You see, the reason I already got positive is I have two negative signs, okay, so then you do that calculation, then you get a value as negative 97.9 kilojoule. Okay, once you get to this value, think about it. You have delta G naught smaller than 0. You go, oh, this reaction will spontaneous go to the forward direction. Then what does that mean to us? That means K, right? Delta G naught is smaller than 0. That means K is going to be bigger than 1. So then you look at all this option. Oh, these ones are, oops, not the last one, right? Those negative ones are not possible. Okay, so like, right, we could give you more options, but if you know the stuff, their options are impossible. Okay, so that's just for that a hint for yourself. Okay, and then from this point we're going to do the same calculation over there, right? So I'm going to use a different color so we can differentiate, maybe gray. Okay, so then you have delta G naught is negative 97.9 kilojoule. Now I don't need to explain, right? We just did it. Okay, and times the temperature for 98K times ln K. Okay, and then you're gonna divide as how we did, but remember that's K. You need to multiply by 1000, and then you do the calculation. This should be ln K equals to 23.65. Then K will equals to e to the power of 23 0.65, then you get 1.87 times 10 to the power positive 10. Okay, so this is how you get to the answer as A. Okay, so as I mentioned, right, so for this chapter, it gives your energy and K, and you know at equilibrium, right, this is the equation you need to use to do the calculation. Okay, and then hopefully this is helpful, and then thank you for listening.